In a single week in 1866, the men working high on Donner Pass burned more black powder than had exploded on some of the bloodiest battlefields of the Civil War. Kegs of it were hauled up the mountain by mule and by hand, and packed into holes drilled by arm and hammer into solid Sierra Nevada granite. The smoke never seemed to clear. The blasts echoed off the canyon walls from dawn until dark. And at the end of that week, after all that powder and all that noise, the men had moved themselves almost nowhere. A few inches a day through the hardest rock in California. The mountain was winning. It had swallowed their labor, their gunpowder, and in some cases their lives, and given back a tunnel face that looked very much like it had a week before. Something had to change. And it changed because of one man who arrived at a frozen lake with an old iron kettle and a liquid so dangerous that the state of California had made it a crime to carry it down a public road. Today, we are going to tell the story almost nobody tells. Not the politicians, not the stock swindles, not the golden spike at the end. We are going to tell the story of the rock itself, and the tools, the powder, and the chemistry that finally broke it. This is the first chapter in a series we are calling the Granite Gauntlet, the engineering fight to drag a railroad across the Sierra Nevada. And this first part belongs to the men who had to defeat the stone. To understand it, we will walk the line the way the work itself moved, from the bottom of the mountains to the summit. First, we will stand at a place called Bloomer Cut, where the Central Pacific first learned what California rock could do to a crew. Second, we will hang on the face of Cape Horn, high above a river, and we will finally settle an argument that has followed that cliff for over 100 years. And third, we will climb to the summit tunnel itself, where black powder failed, where a Scotsman built a bomb factory beside a lake, and where the railroad gambled on the most feared substance of the age. Stay with us all the way to the top, because the most surprising part of this story is not how they broke the mountain. It is the decision they made the moment they finally had the power to break anything they wanted. Let us begin in the foothills, in the year 1864. The Central Pacific had laid its first rails out of Sacramento and was climbing toward the mountains, and for a while the grading was ordinary work. Then the surveyors reached a low ridge near the town of Auburn, and the easy days ended. To keep the railroad grade gentle enough for a locomotive to climb, the line could not go over the ridge. It had to go through it. The cut they needed was about 800 feet long, and in places more than 63 feet deep. That alone would have been a hard job. But when the crews swung their picks into the ridge, the picks bounced back. This was not loose dirt. It was a natural cement, a bed of gravel and stones bound together by clay and time into something that behaved like concrete. The men called it cement gravel, and it was so hard and so stubborn that ordinary digging was almost useless against it. The only way through was to blast it, foot by foot, with black powder. The crews drilled holes into the face by hand, packed them with powder, lit the fuses, and ran. Then they came back, cleared the broken rock by shovel and by one horse dump cart, and drilled again. They moved roughly 40,000 cubic yards of that cemented ground this way, and the work was so impressive for its time that newspapers started calling Bloomer Cut the eighth wonder of the world. When you see the old photographs, you understand why. The walls rise straight and sheer on both sides, hand-cut, with the rail line running dead through the middle of a ridge that did not want to be moved. Let us pause on the black powder itself, because it was the engine of all this early work, and it is easy to take for granted. The powder came largely from the California Powder Works near Santa Cruz, shipped to the railroad in wooden kegs that each held about 25 pounds. At the height of the mountain work, the Central Pacific was consuming powder at a staggering rate. Hundreds of kegs a day during the hardest stretches. More in a single week than was fired in some of the largest battles of the war back east. Think about what that meant just to keep the crews supplied. Every keg had to travel by ship, by wagon, and finally by the backs of men and animals up a mountain grade, to be packed into hand-drilled holes and turned into broken rock. Black powder works by burning fast rather than detonating. The expanding gas pushes and heaves the rock apart along its natural cracks. That makes it forgiving and relatively cheap, but also slow, and it likes a deep, fairly wide hole to do its work. In the cemented gravel of Bloomer Cut, that was good enough. The crews could break a face, clear it, and keep moving. Nobody yet understood that the same powder that conquered this ridge would meet a rock further up the mountain that it could barely scratch. If you are the kind of person who has ever wondered how the big jobs were really done, the actual tools and the actual cost in sweat and lives, then this channel was built for you. Take a second right now to like this video and subscribe, because it tells the people who run the platform to show this history to more folks who care about it the way you do. We spent weeks pulling these details out of old engineering papers and railroad records, and your support is what keeps these documentaries coming. So hit like, hit subscribe, and let us keep climbing. Bloomer Cut is also where this story first draws blood. The man running the construction crews was James Harvey Strobridge, the superintendent, a hard-driving New Englander who pushed men and himself without mercy. One day at the cut, a charge of black powder failed to go off on schedule. Strobridge went forward to check it, and the charge chose that moment to explode in his face. The blast cost him an eye. He wore a patch over the socket for the rest of the great work, and he kept right on driving the line up the mountain. We should be honest here, because you deserve the real history, and not a tidy version of it. The records do not all agree on which eye he lost. Some say the right, some say the left. What they agree on is the cause. A delayed black powder blast, the kind of accident that would happen again and again as the railroad climbed into rock that fought back. That is the thing to hold on to as we go higher. Black powder was the only tool they had for breaking stone, and black powder is slow. It does not shatter rock so much as heave it and crack it. You drill a deep, wide hole, you pack it, you blast, and you hope the rock breaks along the lines you want. In the soft ground of the foothills, it was good enough. But the mountain above them was not going to be soft, and the men did not yet know just how much harder it would get. By 1865, the line had climbed into the Sierra foothills proper, and the surveyors hit the next great problem. The railroad had to round a mountain shoulder high above the North Fork of the American River, at a place that came to be called Cape Horn. The slope fell away beneath the proposed grade, at a steep angle down toward the water far below. There was no shelf to build on. The crews would have to carve one, cutting a ledge into the side of the mountain wide enough to carry a railroad, with the river waiting at the bottom of the fall. Now, if you have heard anything about Cape Horn before, you have probably heard the legend. The story goes that Chinese workers were lowered down a sheer cliff face in woven reed baskets, dangling against the rock, drilling and planting powder while hanging in the air over a drop of 2,000 feet, hauled back up just before each blast. It is a powerful image. It has been printed in countless books and repeated in countless videos. And here is where we keep our promise to give you the real story, because the careful researchers who have spent their lives on this railroad have looked for the evidence behind that legend, and they have come up nearly empty-handed. The basket story does not appear in any record from the time the work was actually done in 1865 and 1866. It shows up much later. One of the earliest versions appears in a tourist guidebook years afterward, and a fuller version turns up in a railroad company magazine in the 1920s, more than 50 years after the fact. The engineers who reported on Cape Horn while the work was underway did not describe baskets at all. The chief engineer of the line, Samuel Montague, wrote in his own report that the work at Cape Horn had proved less difficult and less expensive than first feared. What the early records do support is simpler and, in its own way, just as striking. The men who broke the first standing ground on that slope were held by ropes while they worked, not woven baskets dangling in open air over a 2,000-foot void, but workers roped to the mountain on a very steep face, cutting the first narrow footing where there had been none. And the cliff itself is not what the legend claims. The drop at Cape Horn is real, and it is frightening, but it is closer to 1,300 or 1,400 feet to the river, not the 2,500 feet of the tall tales. The slope is steep, around 75 degrees in the worst stretch, but it is a slope, not a vertical wall. The rock there is not even the hard granite of the high country. It is a slate that breaks away with reasonable effort under a pick and a pry bar. We are not telling you this to take the drama out of Cape Horn. We are telling you because the truth is the better story. Real men roped to a real mountain, carving a real ledge out of crumbling slate hundreds of feet above a river, with no safety net of any kind. That happened. The baskets, almost certainly, did not. And the knowledgeable folks watching this know the difference, which is exactly why we will not insult them with the myth. Why does this matter so much for our story? Because Cape Horn was the warning. It told the engineers that grade work clinging to the side of a mountain was survivable, even at a frightening height, as long as the rock would break. The real test, the one that would nearly stop the railroad cold, was still ahead and still higher. Because above Cape Horn waited the summit, and at the summit the rock changed into something that black powder could barely touch. The climb from the foothills to the summit is a climb into a different world of stone. Down low, the crews had been fighting cemented gravel and slate, hard work but breakable. As the line approached the crest of the Sierra near Donner Pass, the mountain turned to granite. Not the friendly, weathered granite you might picture, but a dense, tight, stubborn rock crossed by seams running in every direction. The kind of stone that swallows a hammer blow and gives back almost nothing. To give you a sense of the difference, the same crew that could break and clear several feet of foothill ground in a day might spend that entire day to gain a single foot in this granite. The rock did not just resist the powder, it resisted the drill. It dulled the steel, and it punished every shortcut. And the railroad did not just have to cut through it on the surface. To keep the grade low enough, the line had to bore straight through the mountain. The crews faced a string of tunnels near the summit, 15 of them in all, and one of them, tunnel number 6, the summit tunnel, would become the hardest single piece of work on the entire western half of the railroad. The summit tunnel had to run 1,659 feet through the granite spine of the mountain, at an elevation of more than 7,000 feet, where winter buried everything under snow for months at a time. The men attacked it the only way they knew, by hand. And this is the part that the heavy equipment people in this audience will appreciate most. So let us slow down and look at exactly how a hole gets made in granite with 1860s technology. There were no machines doing the drilling here. There were men, steel, and hammers. The method was called hand drilling, and it came in a few forms. In single jacking, one man held a star-tipped steel rod against the rock in one hand and swung a hammer of around 4 pounds with the other, striking the end of the steel, then twisting it a quarter turn, striking again, slowly grinding a hole into the stone. In double jacking, one man held and turned the steel, while 1 or 2 others swung heavier hammers, 8 pounds or more, in a steady alternating rhythm, blow after blow, hour after hour. When 3 men worked a hole together, 1 turning and 2 striking, they fell into a rhythm so steady that a hammer was always in the air, one rising as the other fell, the steel singing and turning a fraction between each strike. The man holding the steel had to trust the men swinging the hammers completely, because a missed strike meant a shattered hand, and in the dim light of a tunnel heading lit by candle and lamp, with water dripping and rock dust thick in the air, a missed strike was always one tired swing away. To drill a single hole 2.5 feet deep into that granite could take most of a working day. And they needed many holes for every blast. Then the blast moved the face forward by inches, and the whole grinding process began again. Behind every drilling crew stood a blacksmith, and his job mattered just as much as the men on the hammers. Granite chewed the cutting edge off a drill steel almost as fast as the men could use it. The steel went dull, then it stopped biting, and a dull steel in hard rock is wasted effort. So the blacksmiths worked constantly, heating the worn steels in their forges, reforging the cutting tips, tempering them hard again, and sending them back to the face. A single tunnel heading could burn through stacks of steel in a day. Without the forge running at full tilt, the drilling stopped. It was a whole system, the hammermen feeding dull steel back, the smiths returning it sharp, the holes creeping deeper, all of it powered by human muscle and a coal fire. There is one more thing worth knowing about the men swinging those hammers, because it answers a question that hangs over this whole railroad. The vast majority of the workers driving the summit tunnel were Chinese laborers, thousands of them, and the railroad's own leadership left a clear judgment on how they performed. When the work was at its hardest, the Central Pacific brought in experienced Cornish miners, men from the old mining country of England, who knew hard rock tunneling as well as anyone alive, and the railroad set them to work in the summit shaft alongside the Chinese crews on the same rock. Charles Crocker himself later testified before Congress about the result. He said that the Chinese, without fail, always out-measured the Cornish miners. In other words, the men with no mining tradition behind them, learning the work on the job, drove more tunnel through the granite than the seasoned professionals imported to beat them. The hammers, the steel, and the forge were the tools. But it was the discipline and the sheer endurance of the crews that turned a quarter inch at a time into a finished tunnel. We have reached roughly the halfway point of our climb, so let us get our bearings before we go on. We started at Bloomer Cut, where black powder first met California rock. We hung at Cape Horn and separated the truth from the legend. Now we stand at the face of the summit tunnel, drilling granite by hand a quarter inch at a time, and we are about to meet the substance that changed everything. If you are finding this as fascinating as we did when we dug into it, please take a moment to like the video and subscribe to the channel. It genuinely helps these long-form histories reach the people who love the engineering side of the past. Now let us talk about powder, and why it was about to fail. Through 1866, the crews drove at the summit tunnel with black powder, and the numbers were brutal. From each face of the tunnel, daily progress was often about 1 foot. 1 foot of tunnel for a full day of drilling, blasting, and mucking out the broken rock. With 4 faces working, 2 from the outside ends, and 2 more from the center, which we will explain in the next part of this series, the math was still terrifying. At a foot or so a day, through more than 1,600 feet of granite, the summit tunnel threatened to take years the railroad did not have. The Central Pacific was in a race for government land and money, mile by mile, against the Union Pacific building west across the plains. Every day lost in the granite was a day and a fortune lost to their rivals. Black powder simply could not break the rock fast enough. The mountain was setting the pace, and the mountain was slow. The engineers knew there was something better in the world. On the other side of the country, a different tunnel was being driven through a mountain in Massachusetts, the Hoosac Tunnel, and the men there were experimenting with a terrifying new liquid explosive called nitroglycerin. It was many times more powerful than black powder. Where powder heaved and cracked, nitroglycerin shattered. It could break more rock from a smaller, shallower hole, which meant less drilling for more progress. For a railroad losing a race in the granite, that was the prize. But nitroglycerin had a horrifying reputation, and it had earned every bit of it. In April of 1866, a crate leaking an unknown oily liquid was sitting in a Wells Fargo Company office in San Francisco. No one knew quite what it was. It detonated. The explosion tore the building apart and killed around 15 people, scattering wreckage across the street. The liquid was nitroglycerin, leaking and unstable, and the disaster terrified California. The state responded by effectively banning the transport of liquid nitroglycerin on public roads, which left the Central Pacific with a hard problem. They wanted the most powerful tool in the world to break the summit granite, and the law now said they could not carry it up the mountain. So they did something audacious. If they could not transport it, they would make it on the spot, at the work site, high in the Sierra. To do it, they hired a chemist, a man named James Howden, who set up shop near the western end of Donner Lake, almost in the shadow of the tunnel work. He had approached the railroad's leadership in Sacramento and offered to manufacture the explosive himself, and he was hired for around $300 a month, plus the cost of his ingredients. And here is the detail that tells you everything about how raw and dangerous this era of engineering was. Howden's nitroglycerin factory was not some gleaming laboratory. By the accounts that come down to us, it was little more than a shed roof on posts, and under it, an old iron kettle that served as the nitrator, the vessel where the acids and glycerin were combined into one of the deadliest liquids known. The chemistry is unforgiving. You add glycerin slowly into a chilled mix of nitric and sulfuric acid, and if the temperature climbs too far at any moment, the whole batch can detonate and take the man mixing it with it. The ingredients, the acids, and the glycerin were the parts that could be shipped legally and combined safely only at the end. Howden brought them together at the lake, mixing explosive by hand, batch after batch, and producing something like 100 pounds of nitroglycerin a day at a cost of well under $1 a pound. They ringed the place with red warning flags so no one would wander in. A bomb factory under a shed roof, beside a frozen lake, 7,000 feet up a mountain. Did it work? It worked beyond what anyone hoped. We are not going to guess at the numbers, because for once we have them straight from the engineer who was there. John Gillis, an engineer on the tunnels, later wrote up the work for the American Society of Civil Engineers, and he recorded the comparison directly. In the upper part of the tunnel headings, the average daily progress with black powder had been about 14 inches. With nitroglycerin, it rose to about 22 inches, an increase of more than 54%. In the lower section, the bottoms, the gain was even larger, climbing from somewhere around 17 inches a day, with powder to well over 4 feet a day, with nitroglycerin, a jump of more than 70%. Those are not small improvements. On a job where every single day in the granite was costing the railroad ground in its race against the Union Pacific, a gain of half again as much tunnel per day was the difference between finishing and failing. And the reason for the gain is pure engineering, the kind worth understanding. The nitroglycerin needed a much narrower hole than powder, a little over an inch wide instead of 2.5 inches. Drilling is the slowest, most punishing part of the whole job, so a narrower hole meant far less hammering for every blast. The liquid also did more with less. The crews could load roughly 2 nitroglycerin holes in the time and space that 3 powder holes had required, and each one broke more rock. It cleared its own broken stone more cleanly off the face, and it kept working even in the wet seams where powder fizzled and failed. On the cost side, the difference was real money. By the engineer's own reckoning, blasting with nitroglycerin ran around $10 for every cubic yard of rock removed, against nearly $15 a yard for black powder. And on the summit tunnel alone, that saving ran into many thousands of dollars, even after paying for Howden and his dangerous kettle. One of the railroad's own leaders, Edwin Crocker, summed it up in 2 words: nitroglycerin tells. It did. The mountain that had been giving up inches began giving up feet. You would think that would be the happy ending of this chapter. The railroad found the super tool, beat the rock, and never looked back. But that is not what happened. And the decision they made next is the part of this story we find most remarkable of all. Before we get to it, do us a quick favor, because this next turn is the one that surprised us most when we found it. If you are enjoying this, hit that like button and subscribe to the channel. It truly helps these documentaries reach more people who appreciate how things were actually built. Now, the twist. With the summit tunnel finally broken through by the end of 1867, and with nitroglycerin proven as the most effective rock breaker they had ever used, the Central Pacific turned around and largely stopped using it. Charles Crocker, the man driving the construction, ordered it set aside. After all that, after the kettle by the lake and the danger and the triumph, they went back toward black powder for much of the remaining work. Why on earth would they do that? The reasons are a window into how engineers actually weigh a tool, beyond raw power. First, the danger never really went away. Making and handling nitroglycerin at the worksite had cost lives, and every batch was a gamble. Second, there was the matter of patents and cost. The rights to nitroglycerin were tangled in legal claims and fees, and the men who ran the railroad did not love paying them. Third, and this is the practical engineering heart of it, nitroglycerin was almost too violent for some of the work. On open cuts and grading, where you wanted to break rock loose so it could be loaded and reused as fill, nitroglycerin tended to blow the material clean off the mountain, scattering the very rock they had hoped to keep. Black powder, slower and gentler, left them usable broken stone. The most powerful tool was not the best tool for every job. A good engineer reaches for the tool that fits the work, and for much of what remained, the old powder fit better. So they buried the bottles, in Crocker's blunt phrase, and got on with it. Think about what that decision really tells us. These were not men in love with technology for its own sake. They adopted the most feared explosive on Earth when the granite of the summit gave them no choice. They made it themselves in a kettle. when the law said they could not buy it. They wrung an enormous gain out of it, and then they put it back on the shelf the moment the job no longer called for it. That is engineering judgment, the same judgment you see in any great builder, knowing not just how to use power, but when to hold it back. And it stands in sharp contrast to that other tunnel back east. At the Hoosac, the engineers leaned into the new machine age, driving their headings with compressed air drilling machines and committing fully to nitroglycerin made on site, even pioneering the use of electric firing to set off many charges at once. The Central Pacific had tried the new drilling machines, too, and found they could not make them work in their conditions. The story goes that the crews could not keep the machines fed and running fast enough to beat the men, and so they set the machines aside and trusted human hands and hammers all the way through the granite. Two great tunnels, driven through two great mountains at the very same moment in history, one trusting the coming age of machines, the other beating the rock with muscle, steel, and a liquid made in a kettle. Both of them won. That contrast, the hand against the machine, is a story we will come back to. So let us stand back and look at what these men accomplished in this first fight. They started in the foothills at Bloomer Cut, learning the hard way what California rock could do, paying for the lesson with Strobridge's eye, and the first lives lost. They carved a ledge across the face of Cape Horn, roped to a crumbling slope hundreds of feet above a river, doing something brave enough that it did not need the legend later wrapped around it. And they climbed into the granite of the summit, where they drilled by hand a quarter-inch at a time, where black powder nearly defeated them, and where a chemist with an iron kettle gave them just enough of an edge to win. They did it with tools that would look almost primitive to us now. Hammers, hand steel, a coal forge, kegs of powder hauled up by mule, and bottles of a liquid so dangerous they had to brew it themselves beside a frozen lake. There were no drag lines here, no power shovels, no diesel engines, nothing but muscle, fire, and chemistry against a mountain of stone. And somehow, foot by foot, the muscle and the chemistry won. The rock was broken. The line could climb. But breaking through the mountain was only the first of the Gauntlet's challenges, and in some ways not the cruelest. Because once the summit was conquered, the men still had to hold what they had won against an enemy that came every winter and buried the entire railroad under 40 feet of snow. The summit tunnel they had bled to dig would soon be threatened by avalanches sweeping whole work camps off the mountain. And the engineers would answer with one of the strangest structures ever built. A wooden roof nearly 40 miles long laid over the top of a railroad. A building so long that people called it the longest house in the world. That is where our story goes next. If this is the kind of history you want more of, the real engineering behind the places everyone thinks they already know, then you are in the right place. We have taken apart the Hoover Dam, the Empire State Building, the Golden Gate Bridge, and the interstate highway that today runs right over this same Donner Pass, and a great deal more, all from the same angle: how it was actually built and what it cost the people who built it. So do the channel a favor. Hit like if you made it this far. Subscribe so you do not miss part 2 of the Granite Gauntlet, where we follow the railroad into the tunnel itself and meet the buried locomotive that powered the dig. And tell us in the comments which structure you want us to take apart after this one. Thank you for watching, and we will see you on the next one.